Rivers are in a constant state of flux, which means that it's hard to tell if the changes you're seeing are due to something that you've implemented or rather just a seasonal variation. The last time we were here in Barrydale, we learned two things about the Hayes River. There's not enough water in the system and they're facing declining water quality. Since then, a number of interventions have been implemented and some of them are still ongoing. So now the questions are, what have we done and what impact has it had? Because ultimately, all of this effort is to protect the habitat of a critically endangered fish species, the Tradouw Redfin. If we want to improve conditions for the redfin, one of the first things we need to do is understand and maximize how much water is actually in the river, especially during dry periods. And this is surprisingly difficult to do. One of the factors affecting baseflow here is the invasive alien plants growing along the riverbanks. These plants use a lot more water than the indigenous vegetation, which means less water makes it into and stays in the river. So the most immediate action has been to remove them. The Tradouw Conservancy has cleared large sections of the riparian zone in the agricultural areas as well as through the town itself. Last time we were here, this stretch of river was absolutely clogged with invasive plants. There were beefwood, Port Jackson, and black wattle. Now the Conservancy's actually done a first pass of the alien clearing and soon to do a follow-up. It sounds straightforward, but in practice it's not. In rural areas, you might be dealing with one or two landowners at a time, just because the land parcels are so much bigger. However, in town, it's dozens of landowners, each with their own concerns and access constraints. Despite this coordination challenge, the Conservancy have managed to get broad support and the work has been moving steadily forward. Alien clearing creates jobs, and the Conservancy actually trains teams in chainsaw operation, herbicide application, health and safety, and first aid. They also organise snake awareness courses, firefighting, and working at heights. So while the goal is to free up water for the river, it's also building local skill sets and creating jobs at the same time. But even if we remove all the invasive alien plants from the catchment, we know that there's still pressure from the water users on the system. We know that the Hayes River, for instance, is the sole source of water for urban and agricultural use in the town. So we still need to understand what water is actually available to take. And that's where our water monitoring system actually comes in. At the beginning of this project, we installed a series of water level sensors along the river. These give us a continuous picture of how much water is moving through the system, how much is being abstracted, and how much is making its way downstream. For the first time, we're starting to see the river as a system rather than just a series of isolated observations. But there was a missing piece. To really understand a river, you also need to know how much rain is falling and where. There is a rainfall station owned by the South African Weather Services in the catchment. However, it's located at the bottom of the catchment, which might be fine in some cases, but Barrydale sits on the edge of the Klein Karoo, and most of the rain in the Hayes catchment actually falls up in the mountains and not in the town. So we've purchased a new rainfall station to install higher up in the watershed. It's been quite a mission working out how exactly to install a rain gauge on the top of a mountain. It's a 9-kilometer hike up and a 700-meter elevation gain, so you can't bring heavy equipment or use anything needing a power supply. However, the Conservancy really pulled together and came up with a rather brilliant, if labour-intensive, plan. It's not the easiest site to get to, which is why Aileen and Philip are making the trek up the mountain and not 6 months pregnant Frankie.
Once we have both pieces, rainfall and river flow, we can start to connect the dots. How much of the rain actually becomes river flow, and how much is being used along the way, and crucially, how much is left for the river itself and for the species that depend on it. To answer that, we've been building a water balance tool, a tool developed by Bruce Paxton and Gerald Howard, which is a simple hydrological tool that scales down our large catchment models to smaller catchment systems.
It allows us to understand whether the water users in the system are A, sharing the water equitably amongst themselves, and B, leaving enough water for the environment. And if not, it tells us how much they need to reduce their water usage by in order to meet the environmental water requirements.
It's still a work in progress, and we're refining it as we improve our assumptions about water use and our rainfall data. We will work with water users to calibrate the model and ensure reasonable and trustworthy results. Hopefully, this can lead to informed and optimized water use within the catchment.
We're starting to understand water quantity in the system, but that's only telling us half the story. The other half of the story is water quality. Upstream, the water quality is looking pretty good, but downstream is telling us a different story.
And this is where things get a bit more complicated. With water quantity, you can measure flows, track changes, and start linking cause and effect. Water quality is not as straightforward. Pollution often comes from multiple sources at once, and not always in obvious ways. There are two types of pollution sources, diffuse and point source. Diffuse pollution is when a whole area is contributing to the pollution of the river. For instance, when it rains, water runs off roads, agricultural fields, and gardens, picking up nutrients, sediments, and contaminants along the way, and carrying them into the river. In Barrydale, there's also the potential that the septic tanks in the town centre aren't functioning properly or are overflowing during storms, adding to the diffuse pollution from the runoff.
The challenge is that these sources are difficult to isolate and address. There's no one thing to point at and say that is the source of the pollution.
Part of the response here is simply awareness, making sure people understand the role they play in maintaining the system, especially when it comes to managing and emptying their septic tanks. We can't rely on behavioral change alone, so alongside awareness, there's been a more physical intervention along the riverbanks. The aim is to increase the buffer zone between human activity and the river. So in areas where invasive plants have been cleared, the Conservancy and its contractors have been planting indigenous riparian vegetation. As runoff moves through these vegetated areas, nutrients can be taken up by the plants, effectively reducing the pollutant load making its way into the river. These plants also help stabilize the banks and reduce erosion.
Now, it's not a complete solution, but it is something that we can do where we can. And it is a way to improve the conditions by using the natural processes of these plants to treat the water.
In the previous video, we saw that fish downstream of town were affected by parasites. That's often a sign that something in the system is out of balance. So the Conservancy invited researchers from the Northwest University to investigate this. Their aim is to understand what conditions are allowing these parasites to thrive and whether those conditions are linked to water quality, but also whether the parasites are actually negatively impacting the fish. If they are, it gives us another way to track whether the system is improving over time. We've spoken about diffuse pollution, but the easier pollution type to address is actually point source pollution.
In this tributary of the Tradouw River, we've got two sources of pollution. The first is that this sewer pipeline has a series of manholes that frequently block and overflow. The second source of pollution is that the wastewater treatment works is drastically undersized for the amount of sewage it needs to treat.
An upgrade to the treatment works is planned, but construction hasn't started yet. In the meantime, the municipality is raising manholes in Smithsville to reduce the frequency of spills. It's not a permanent fix, but it should help limit some of the immediate impacts. We are rehabilitating a small municipal dam in this tributary, which has previously been impacted by sewage inflows. This intervention may solve several problems at once by improving the water quality of the tributary and by providing access to water to the small-scale farmers in this area. The Conservancy secured funding for a contractor to clear the dam of reeds, remove the sediment buildup, and repair the dam embankment. The upgraded sewer line and raised manholes should reduce the risk of sewage spilling into the dam and undoing all of our good work. But to mitigate the remaining risk, the Conservancy has identified areas for planting. The idea is to slow down and passively treat incoming flows before they enter the dam, again using vegetation as a kind of natural filter. To make that possible, they've even established a wetland plant nursery where locally collected seeds are propagated for use in these restoration efforts. So while the broader system challenges are still being worked on, there are already smaller, practical interventions improving conditions on the ground, both for people using the water and for the river itself.
What I like about an intervention like this is that it has a host of benefits, again, beyond just conservation. So we've employed a local contractor to do the excavation. We've also created a job for the restoration team, which incidentally is also trained by the Conservancy. The Conservancy's managed to set up a wetland nursery so that they're prepared for projects like this in future. And we're providing secure water supply for small-scale farmers. Overall, it's just a huge win. So on the one hand, we're starting to understand how much water is in the system. And on the other hand, we're starting to tackle the more complex problem of water quality, where the pollution sources are, and particularly how to deal with sources of pollution that are not a single point. We need both of these to understand how to improve and protect the habitat of the Tradouw Redfin, because for a river to function properly, we need enough water and it needs to be clean enough. Now, we're still in the beginning stages of this project. We're still going to be continuing to implement interventions, and critically, we're still going to monitor to understand how successful we've been and to inform future interventions to make sure they're backed by data and science. So that's where we are now. We're here in the middle, and we're still going to see how successful we will be.